Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! Here we're given two angles on parallel lines, and the parallel lines are here and here. And if we draw the line that they are on, then it creates a little C shape. Now, whenever we were dealing with C angles, we call them either interior, co-interior, or allied angles. And what we know about interior angles, I'm just going to call them, is that they add up to 180. So we can get that 20x, and we can add to the 40x, and we know that that equals 180 degrees. And I need to make sure I write down the reason, because they're interior angles. So here I'm going to be solving this algebra. I'm just getting my tramlines in. 20x plus 40x is 60x equals 180. And we're going to divide both sides by 60 to get x on its own. So we can solve it. And we've got x equals 3. So the value of x will be 3. For this question, it's really useful to label angles that you know on the diagram, even if you can't go straight to the answer. So I know that if I extend this line here, but let's do a bit of a better job of that. So if I extend this line here, the north line, then I can work out what this angle is, because it's going to be the same as this angle here. And the reason is it's Z angles, which are alternate angles. So I know that this angle is 35 degrees because of alternate angles. The question asks to find the bearing of C from B. So we're at B and we're finding the angle that C makes from north going clockwise. Well, it's going to be this angle here we're looking for. And if we look, we already know what this side is, which is 180 degrees because it's a straight line. We've got the 35 degrees there, and we've got the 21 degrees. So it's going to be 180 plus 21 plus 35. It doesn't matter which order we add them, which will equal 236 degrees. To find the average rate of petrol usage, which I'm just going to call rate, what we're going to do is we're going to get the distance travelled by the car, and we're going to divide that by the amount of fuel used, so the volume of the fuel used. So the distance was 135 kilometres. The volume of the fuel used was 9 litres. We do 135 divided by 9, which is 15. So it's 15, and this was in kilometres, and this was in litres. So it's going to be 15 kilometres per litre. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimetres high. And how wide will it be? Well, it will be 2 centimetres wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimetres wide and 1, 2, 3, 4, 5, 6 centimetres tall. There we go. And make sure that you don't add any three-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly two-dimensional. To answer this question, we're going to have to create a two-way table for all the information. So I'm just going to draw a quick table. So we've got maths, English, science, then a total column. And then across here we have male and female and a total column. Okay, so gonna fill in maths at the top, English, science, and then we have a total. And then we've got male, female, and then total at the bottom. So looking at the information we have, it says there are 43 students who are male. So altogether the total male is 43. 30 out of the 52 students who went to science were female. So we're just looking at science, and 30 were female, and it says there were 52 altogether. 37 students went to English, so total for English was 37. And then 17 females went to maths. So looking at maths and females, which would be there. So that's all the information we're given, apart from the 115 as well. There we go. So we start filling these in. So looking at these two, if there are 115 students altogether and 43 were male, that means 72 will be female. Looking along the bottom here, the total of English was 37, the total of science was 52, and the total altogether 115. And notice I'm not necessarily reading the question here, I'm just filling out the two-way table, but we'll read the question at this point. So it says work out the number of males who went to English. Males who went to English will be this box here, so this is our target. But you can't work that out directly, we've got to kind of go around and work out what we can. So the next thing we can do is work out this bit here. So the total females 72, the females who went to maths 17, females who went to science 30, so that leaves 25. And then you can see here we can work this out. So the total was 37 who went to English, 25 females, and so that means there will be 12 males. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds, and we're going to do that by finding out what €1 is and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we go times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours, that's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. And I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5. Then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint. So our midpoint effectively becomes the t. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. There's a few different methods to find product of prime factors, but I prefer using the bubble method. So we put a circle around 75, and we want to split it up into 2 numbers, so 2 numbers that multiply together to make it. I always pick the smallest that I can think of, which is normally 2, but in this occasion the easiest one for me would be 5. I think also 3 goes into it, but 5 to me seems nice and easy. It doesn't always have to be the smallest that I pick. So 5 times what is 75? Well, 5 times 15 is 75. And then to make 15, we're going to do 3 times 5. And the reason why I've done some of these bubbles in red is that those are the prime factors, which means they can go to 1 and 5. But if you do 1 and 5, you'll be there all day. So we always stop when we do the prime numbers. And so we're going to write these in a list. So 3, 5, and 5. The product means that we put a times sign between them. But if you notice here, we've got 5 times 5. So a different way of writing that in index form is 5 squared. So our answer will be 3 times 5 squared. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my two circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900. And that's it. So our answer is 9,900. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55. And it's going to be 0.55 times the amount of days. Well, it says the amount of days is X. So it's going to be 0.55x. Then it says that there's just a one-off cost of £15. So you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. The important thing when choosing a sample is that everyone has an equal chance of being picked. So if you look at method 1, picking the first 30 students who enter the school is going to have a bias, because there might be a difference in the type of person who arrives early to school to the type of person who might arrive later. If we select a class in the school, then they're generally all going to be the same age. So if it's a year 7 class or a year 11 class, they're all going to be the same age. It might seem that it's fair that picking the first 30 students alphabetically, so A to F or whatever, again, that's not fair, because the people at the end of the register don't have an equal chance of being picked. So you need to make sure everyone in your population has an equal chance of being picked. So picking 30 students out of a hat containing all the students' names in is definitely the fairest way of picking a sample from this list. If we try and visualize this question on a graph, then we've got C, which is somewhere here. So we've got C, which is somewhere here at coordinates 2, minus 12. And we've got D, which is somewhere here at coordinates 8, 4. And we're asked for the length of the line segment. So we're asked for this distance here. Now we can see that we can actually make a right angled triangle with this line segment. And we've got to find out what each of the sides is going to be. So the bottom one starts at x coordinate 2 and D it goes to x coordinate 8. So it's going to be 8 take away 2, which is going to be 6. So the distance there is 6. And how far does it go up? Well, we've gone from minus 12 to 4, so that's gone up 16. And we know that when we've got a right angled triangle, which this one is, and we're asked for one of the lengths, having given the other two, we're going to be using Pythagoras. So for Pythagoras, label the sides A, B and C, with C being the one opposite the right angle. And we write down the Pythagoras' theorem, which is a squared plus b squared equals c squared. A squared we've said is 6, b is 16, and 6 squared plus 16 squared is going to be 292. And then we're just going to quickly solve this by square rooting both sides. And so we're left with 17.088 blah 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 is equal to C. And because it asks it to 2 decimal places, we're going to write the answer of 17.09. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. When proving two triangles are congruent, and congruent means exactly the same, we're going to have one of 4 answers. Either side angle side is the same, angle angle side, or angle side angle. Side 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 are the same, or they have the same right angle, hypotenuse and side. This question doesn't have a right angle, so we can cross that out. It has 2 lengths, so 2 sides, but not 3, so we can cross that one out. It only has 1 angle, so we can cross this one out. So we're looking to see whether it has the same side, then angle, then side. So here we've got 13 as a side, then 139 as an angle, then 6 as a side. 13 as a side, 139 as an angle, and then 6 as a side. So they have the side, angle, side. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. To find the gradient of a line, we need to find 2 coordinates that we know. So I've got this coordinate here and this coordinate here. Now I don't really know what this coordinate is, that's why I've not picked one. You need to pick coordinates you know. And what we do is we just draw a right angled triangle between them. Try and get this nice, there we go. And the gradient, which we call m, is the change in y. How much has y changed over the change in x? So the change in y is going to be 4, because it's gone up 4. And the change in x is 3, because it's gone to the right 3. So our answer will be 4 over 3. To find the error interval, I start by just drawing a number line. And we're going to put the number in, so 50.14. And we're going to think to ourselves, well, what would the next number down and the next number up be? Well, it's the nearest hundredth of a gram, so the next number down would be 50 50.13, and the next number up would be 50.15. Then to find the lower bound and the upper bound, or the highest and lowest it could be, we just find the halfway points between those two. And so the halfway point here is 50.135, and the halfway point here would be 50.145. So the lowest it could be is 50.135, the highest it can be is 50.145, and it asks us to use W for the weight, and we're going to show this with inequalities. Now it can be 50.135, so it's larger than or equal to 50.135, but it can't be 50.145 exactly, otherwise it would round to 50.15, so we don't put the line underneath the inequality. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism, so the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now A and B are the two parallel sides, which will be this one and this one, and then the H is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, for this, will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. We're going to start by drawing a table of values. We draw the table of values because we've got a curve here, and with a curve you need quite a lot of coordinates to make sure you get the curve right. Now ideally I'd go up in halves, but so that I'm not just sitting here writing numbers, I'm going to go up in ones on this one. I'm going to leave a space there though, and we'll see why in a second. So what I'm going to do is type these into a calculator. I'm going to type in 0.5 times brackets minus 2 close brackets cubed plus 8 into the calculator, and that gives me the answer of 4. I'll do the same with minus 1, that gives me 7.5, 0 gives me 8, 1 gives me 8.5, 2 will give me 12, 3 will give me 21.5. The reason I've left a space there is this axis doesn't go up to 21.5. So what I'm going to do is just do 2.5 to see if it goes up to that, and that should be 15.8125. So that's actually quite useful because that shows that it's not quite 16. So we were aiming for roughly where 16 is. So next thing we do is plot these coordinates. So 2 would be at 4. Minus 1 is 7.5, which we can't be perfectly accurate for, but it's roughly there. Then 0 is 8. Then 1 is 8.5, roughly there. 2 is 12. And then 2.5 is just below that 16. So it's almost at 16. Then the next thing we do is just join it up with a nice smooth curve. It's sometimes helpful if you turn your paper sideways. Obviously I can't do it when I'm on this computer, But you want to just keep drawing and don't lift your pen off at all. Just go with the points. And you want to avoid things like feathering, which is like that. We do that kind of thing. And you kind of want to avoid, or you want to make sure you go through the coordinates. And you just make it a nice smooth curve. The exam is very forgiving when it comes to curves. They know that not everyone's got the steadiest of hands. So as long as yours goes through the points and doesn't have like gaps in it or feathering or anything like that, and it's just one continuous smooth line, then you'll get the marks. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now, they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69, and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. To be able to work out this question, we need to work out the amount of student hours required to paint the wall. And to work that out, we've got 6 students and it takes them 11 hours. So 6 times 11 means it's going to take 66 student hours. So if we had 1 student, it would take 66 hours. 2 students would be half of that because they share the work, and etc, etc. So here we've got 6 students and it take 11 hours, and it says how long will it take 7 students. Well, if there's 66 hours or student hours but they're sharing the time, we just divide 66 by 7. So 66 divided by 7 is 9.428 blah blah blah, and it says it wants its 2 decimal places, so it will take them 9.43 hours. Now check this makes sense. We've got 6 students and it takes them 11 hours. So we'd think if we had more students helping to paint the wall, it would take less hours. So we've gone from 11 hours to about 9.5. So that sounds right. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet, but they're all factors of 45. So we're going to times top and bottom of the first one by 9, so we end up with 9k over 45. We're going to times top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k, and then 3 plus 4, which is just 7 over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1, and then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. So we draw a line up from 18. Should be this one here. Then we draw a line across. Now to me that is just above 55, so it would be kind of 56, maybe 57, somewhere around there. Let's say it's 56. So 56. But let's just draw that a bit further out so we can see it. So we're saying this is 56. Now that's 56 below. There are 56 values below that. But this is asking us to find the ones above 18. So if there's 56 below, look at where it goes up to. It goes up to 100. That's the maximum. So all we need to do is we need to do 100 minus 56. We're basically finding the amount that's above it, so this amount here. And when you do 100 take away 56, you get the answer of 44. Now if you get a slightly different answer, say if you got the answer of say 41 or 42, somewhere around there, that's absolutely fine too. So you can be a little bit off because it's sometimes quite difficult to read these graphs, and the exam will always give a range of values, but make sure you show you're working out. We're going to start by drawing x equals 3.5 onto our graph. So x equals 3.5 will be a vertical line where x is always 3.5. And we're asked to find x is equal to or greater than 3.5. So where on this graph is greater than 3.5? Well, it's going to be on the right hand side of it, because all the coordinates here are more than 3.5. It's got to equal to and greater than. The equal to means that it will be a solid line rather than a dashed line. So the first thing we're going to do is just write out the sequence. So 25, 40, 65, 100, 145. And we're going to just find the differences. So this is going up by 15. And then this is going up by 25. So they're not the same. This is now going up by 35. And then this by 45. So the differences aren't the same, but the difference of the differences is the same. And when you've got a difference of differences being the same, we've got a quadratic sequence. So the first thing you do with a quadratic sequence is get the amount of that it's going up at the difference of the differences, so the plus 10 here, and simply get that 10 and divide it by 2. Always divide it by 2, always halve it, and that gives us 5. And we can actually fill out the first bit of our answer, because that 5 will be the coefficient of the n squared, so it would be 5n squared. Simple. The next bit is a bit more tricky, because what we've got to now do is remove that 5n squared from our sequence. So I'm just going to do a quick table. You don't need to do a table, but it's sometimes a bit easier. And we're going to have our term number, so term here. So we've got number 1, 2, 3, 4, and then the fifth term. Then we've got our sequence here, which will be our 25, 40, 65, 100, and 145. Now, what we want to do is remove the 5n squared from our sequence. So what we're now going to do is add a 5n squared sequence onto this table. So we do 5 times 1 squared, which would be just 5. And then 5 times 2 squared, which would be 20. 5 times 3 squared, 45. 5 times 4 squared, 80. 5 times 5 squared, 125. And what we're going to do is remove that from our sequence. So we're going to get our sequence and just remove or take away the 5n squared and see what we're left with. So 25 take away 5 is 20. 40 take away 20 is 20. 65 take away 45, 20, 20, 20. So what this is saying that once we remove the 5n squared, there's still 20 left. And so all we need to do to our sequence is just add that 20 on. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. So we're going to start by labelling the sides here. So we've got capital A up here, little a down here. It doesn't matter which one you label. Capital B here, little b here, and capital C here, little c here. So you notice the C's aren't really involved at all, but we've got the two A's, we've got the capital A and the lowercase a, and we've got the capital B and the lowercase b as part of the question. And so when you've got a pair or two pairs of angle and sides, you are going to be using the sine rule. And so the sine rule says that sine capital A over lowercase a is equal to sine capital B over lowercase b. Now you might be wondering why I've put sine A and sine B at the top, when sometimes this is written as the lowercase a and lowercase b at the top. Well, if we're looking for the angle, which we are here, we're looking for capital A, you put the angles at the top. If you're looking for the length, you put the lengths at the top. Okay, so we're going to fill this in. So sine, we're just going to leave that as sine A, so it's just, or sine x actually, shouldn't it be? Sine x over, and then lowercase a is 6, equals sine B, the angle is 35, over lowercase b, which is 7. Okay, we're going to work out what the right hand side is. So that's going to be 0.081 blah blah blah. And then we're going to be solving this. And the first thing we're going to do is times by 6 both sides. So we get sine x is equal to 0.491 blah blah blah. And then we're going to inverse sine both sides. And so we have x equals 29.448 blah blah blah. And our answer wants to be rounded to 2 decimal places. So we're going to put our answer as 29.45 degrees. So there are two things with this question. There's the negative power and there's the half. And we're going to deal with them separately. So to deal with a negative power, all you need to do is put the whole thing over 1, or 1 over the whole thing, I should say. And it's nothing more complicated than that. We just copy the same thing again, but this time instead of it being negative a half, it's just to the power of a half. So that's dealt with the negative. Now to the power of a half means square root. So whenever you see anything to the power of a half, it just means square root. So let's deal with the 16 and the x to the power of 16 separately. Now with the 16, we're going to square root it, because to the power of a half just means square root. So square root of 16 is 4. Now with the x to the power of 16, there is another rule in indices that say if you've got a power on the inside and a power of the outside, you just multiply them together. So 16 times a half is 8. So the answer will be 1 over 4x to the power of 8. So we're going to start off just by copying down the same equation. And we're asked to make b the subject. So we're going to put our solving lines in. So the first thing we need to do is get rid of this 10 here. So we're going to divide both sides by 10. And that will mean we have a fraction here, a over 10. And we've got the square root b over 3. Now we need to get rid of that square root. So what I'm going to do now is square both sides. Now to square a fraction, we square the top of the fraction and we square the bottom of the fraction. 10 squared is 100. And that will equal b over 3. And we want to get rid of this next, so we want to times both sides by 3. To get rid of a divide by 3, we times both sides by 3. Now with a fraction, when you times it by something, you actually just times the numerator, the top, by that. So it's going to be 3a squared over 100 equals b. So b is 3a squared over 100. We're asked to solve this quadratic, and we're told that we're going to leave the answers to 2 decimal places, so chances are we're using the quadratic formula. So for the quadratic formula, we're going to use a, b and c. We'll go find a, b and c. A is the coefficient of the x squared. Now, we don't actually have a number before the x squared. Well, we kind of do. There is a 1 there, we just don't bother showing it. So a is 1. B is the coefficient of the x, which would be minus 15. And c is the number left over at the end. We're going to write down the quadratic formula, but instead of a, b and c, we're going to feed in the values that we've got. So it's minus b, always put them into brackets, plus minus square root of b squared. So I always put a, b and c into brackets, because here if you don't have the brackets, it will square the 15, then put a negative before it. It won't be correct. And I just put brackets for each of the numbers, so 4 times 1 times 6, because if you put brackets around all of them, you'll never ever have that problem. And then 2 times 1. Put that into our calculator with a plus there, and you will get the answer of 14.588 blah blah blah. Go back on your calculator and change that to a minus. Most calculators have cursor keys. You can go back and delete it and change it, and you get 0.411 blah blah blah. So to 2 decimal places, our solutions are 14.59 and 0.41. Okay, so first thing I'm going to do is just a quick sketch of this diagram. So we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. says it wants its 2 decimal places, so it will be 21.61. So we first of all need to work out the frequencies in each of the bars, and we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total, and they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. I'm going to start off this question by finding length BD, and we do that by doing a little right angle triangle down here, and let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tramlines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same, so therefore point A will be exactly at the midpoint or above the midpoint of the square, so M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. I'm just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5, and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared, and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tram lines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330, and because it says 2 decimal places, we want to write down the answer 4.33 centimeters. As always with this type of question, we want to get rid of the fractions or brackets if we have any. Here we've got some fractions, so we're going to start by getting rid of them. I'm going to start by copying down the question, and I'm going to give plenty of space, because these kind of questions do get out of control quite quickly. And so we've got 2 over x plus 10 over x plus 10, and then we've got equals 7. So I'm just going to scroll down and just give us lots and lots of space. Put my tram lines in for the equals, Okay, first thing I'm going to do is I'm going to get rid of the fraction on the left hand side. I'm going to do that by timesing everything by x. And don't forget, it's not just both sides, you've got to times all the terms. So we're going to times the first fraction by x, which will just give us 2, times the second fraction by x. Well, when you times a fraction by something, you times the numerator. So it would be 10x over, and it would be x plus 10. Denominator stays the same. And here it just becomes 7x. Next, we're going to get rid of the second fraction's denominator. So we're going to times by brackets x plus 10, both sides. Okay, so 2 times x plus 10 is just going to be 2 brackets x plus 10, but I can actually just expand it now. 2x plus 20. Then it's going to be 10x, because the times x plus 10 just gets rid of the denominator. And then here, let's try and expand this as we go. And so we do 7x times x, which is 7x squared, and 7x times 10, which is just 70x. Next step we're going to do is just move everything on the same side. Now, I normally keep the x squareds positive if I can. So wherever the x squared is, I move everything else to that side. So we're going to collect the 2x and the 10x, and we're going to take away 12x from both sides. So we've still got that 20 on the left-hand side, and here we have 7x squared, where is it going to be, plus 58x. I'm going to take away that 20 from both sides, because with quadratics, to solve them, we always need it to equal 0. Right, now, little hint in the question, it says, write your answer to 2 decimal places. That normally means we're going to be using the quadratic formula, and looking at this question, it doesn't look like we can factorize it. So, quadratic formula, we need to know what a, b and c is, or are. A is the coefficient of the x squared, which is 7. B is the coefficient of the x, which is 58. And c is the number on its own, which is minus 20. The quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. So, putting in the numbers, it would be minus brackets 58, and I always put brackets around these, because if they are negative, it makes it a lot easier and a lot more reliable. Minus 4 times the 7 times the minus 20, and all of that is going to be above 2 times the 7. Okay, so we type that into our calculator with a plus, first of all. So you get your calculator out, type all that out, and you should get 0.331, etc. And then on your calculator, you go back to that plus and change it to a minus, and you should get minus 8.62. Oh, hang on, that's not quite right. 8.617, blah, blah, blah. Rounded too early there. And then when you round those, you should get 0.33 to 2 decimal places, and the other one will be minus 8.62 to 2 decimal places. And looking at that, we can see there's a plus 2 inside the function. Plus 2 inside the function actually does the inverse of what you think it will do. You would think it would move the graph twice to the right, because all the things inside the function are normally are to do with the x plane, so they're going to move it left or right, or stretch it out left or right. But actually with a plus 2 you go left 2. So if we pick a coordinate, say this one here, that will actually be over here, and this one here will actually be here, and this one here on our graph will actually be here, and we can just have a look at each of the points, and we'll see a graph will probably go off somewhere there, and then we count twice for this one as well, and probably go off somewhere there. So when we draw the graph, in fact we've got this one down here, when we draw the graph in, the graph will look exactly the same, but it will move to the left 2 squares. So when we have two equations that are both linear, we obviously do solving through elimination. But here we've got a kind of quadratic-y, kind of circular graph on our second one. So we're not going to be able to use the method of working downwards and eliminating the x or the y's. But here what we can do is we can solve through substitution. This first thing says that instead of y we can write 5x. So what we're going to do is just write out the second equation, but instead of y we're going to write 5x. So we've got x squared plus, and instead of y we're going to write 5x, and we're going to put it in brackets because we're going to square it, plus 10x equals 111. So we can actually create a quadratic from this situation. So we're going to just square that. So that's going to be 25x squared plus 10x equals 111. We're going to just put our solving lines in. It's not much solving to do, because all we need to do is take away 111 from both sides to get it equal to 0, which we need to be able to solve the quadratic. So x squared plus 25x is 26x squared plus the 10x, and we're taking away 111 from both sides, so that will equal 0. So looking at the question, it says 2 decimal places. It's a calculator question. Chances are we're going to be using the quadratic formula. So for the quadratic formula we need to find out what a, b and c are. A is the coefficient of the x squared, which is 26. B is the coefficient of the x, which is 10. And c is the number on its own, which is minus 111. So we're going to substitute those into the quadratic formula, which is x equals, and then we put our fraction in, and we've got minus b, and I always put them into brackets, plus minus, and you'll see why if you ever have negatives, so you can get in real problems when you have negatives. It doesn't take much longer to put them into brackets. Minus 4 times a, which is 26, times c, which is minus 111. And then all of that over 2 times a, which is 26. So we're going to do this once with a plus there. And so when we have a plus there, we get 1.882, blah, blah, blah. And when we do it with a minus there, we get minus 2.267, blah, blah, blah. But the problem is those are x values, and when we solve, we've got to also find out what the y values are. Well, we actually have a really nice way of finding out the y value, because if you look at this first equation, it says that y equals 5 lots of x. So all we need to do is multiply these x values by 5. So we're going to times that first one by 5, and we get 9.414, blah, 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 times the second solution of x by 5, and we get minus 11.337, blah, blah, blah. And so when we round those to 2 decimal places, which is what the question asks, we can have 1.88 and 9.41, and we have minus 2.27 and minus 11.34. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.